This is the lesson 1.1, trigonometric ratios in right angle triangles. This is a grade 12 MAP 4C lesson. The learning goals for this lesson are that we are learning to calculate the side lengths of right angled triangles using trigonometry, which is in our case it's sine, cos, and tan. And we're also learning to calculate the angles of right angled triangles using sine, cos, and tan. So there's two things that we're doing in this lesson, calculating side lengths and calculating angles. So now what I'd like you to do is take out the handout that you have been given. Make sure it is printed out in front of you. It looks just like this. And we're going to go through it and take notes together. Please feel free to pause the video if I'm going too quickly, or rewind. Just make sure that you've got all the notes, as this is what is going to help you on your quizzes, assignments, and your tests. So let's start at the beginning. So you've been learning trigonometry since grade 9. You'll definitely have done it in grade 10 and grade 11. But we're going to do a refresher. So we're going to be using something called, let me scroll to the bottom, SOHCAHTOA today, which should look familiar to you from other grades. So when you see the word trigonometry, all that means is trigonometry just studies triangle measurement. So every time you see trigonometry, that's what I want you to think of. Triangle measurement. And we use it simply to calculate side lengths and angles of triangles. That's it. That's what we're doing for this entire unit. So there's different kinds of triangles, and for each kind of triangle we can use a different tool. In this case, in this lesson, we are going to be dealing with right angle triangles. So those are triangles that have a right angle in it. And there's three special ratios that you can use for right angle triangles: sine ratio, cosine ratio, and tangent ratio. So we're going to be practicing with all of them today. So before we can get into sine, cos, and tan, we're just going to do a refresher of how to label a right angle triangle. So just as a reminder, this is a right angle triangle because of this angle right there. That little box indicates 90 degrees, which is the same thing as a right angle. So there's three sides to a triangle. We are calling them something special. One of the sides we're going to call hypotenuse, one of them opposite, and one of them adjacent. So before we get started, I just want you to put this little label that we're going to call this our angle A. So this is the angle that we either have or that we're looking for. This is how we're going to label our triangle in perspective of this angle. Okay, so let's get started. Can you figure out which the hypotenuse is? Do you remember if it's side 1, side 2, side 3? If you said side 1, you are totally correct. How we can tell whether something is a hypotenuse, so my pen is a bit big, but you'll be able to write this really nicely next to hypotenuse. The hypotenuse is the longest side, but sometimes it's hard in a right angle triangle, to tell what's the longest side. So the better way to do it is you can tell that it's the hypotenuse because it's across from the right angle, from the 90 degrees. So we take this 90 degrees and go across, therefore that one has to be the hypotenuse. So I'm just going to write short form HYP here. Or you can just put an H. Let's do the next one now, opposite. So we've got two sides left. If this is the angle in question, which one is the opposite? If you said side number 1, you are totally correct. So how we can tell whether something is the opposite side is that it is across from the angle we are using, or the angle that we're looking for. So in this case, A seems to be blank, so it's A is the angle that we're looking for. Okay, and the last, I'm just going to write OPP for opposite. And the last has to be adjacent. Adjacent is going to be beside the angle in question. Or you can just think of it as the leftover one. All right. So let's go down to the bottom of the page and remind ourselves what SOHCAHTOA stands for. So SOHCAHTOA is just a code to help us remember the three main functions in trigonometry, which are sine, cos, and tan. So the S stands for sine. You can guess that the C stands for cos and this T stands for tan. And then next to sine, cos, and tan, there's two more letters. And the letters are O, H, and A. And what O and H and A stand for is just hypotenuse, opposite, and adjacent. So let's go and label the rest of this code so that we can write out our ratio. So we know that S stands for sine, O just stands for opposite, and H stands for hypotenuse. And then let's do A. Can you guess what A stands for? It is adjacent. ADJ. Hypotenuse. H stands for hypotenuse, we know that. T stands for tan. O stands for opposite. A stands for adjacent. So how to read SOHCAHTOA is we read it from left to right, just like this. So we're going to take the first ratio here. This means that sine is equal to opposite over hypotenuse. And when we go to the next ratio, this means that cos is equal to adjacent over hypotenuse. And then we have the last ratio, tan is equal to opposite over adjacent. So let's write those ratios out. So we're going to start with sine. And you don't just write sine. Sine is a function or relation, so we have to always write sine of something. So some teachers you might see that, which means theta. It stands for an angle that we're looking for that we don't have. I'm just going to write A for our angle. Sine of A equals, and then let's just read it from left to right. It equals opposite over hypotenuse. So that's what I'm going to write. Opposite over hypotenuse. So there is one ratio done. The next one we're going to deal with is cos. So we're going to write that cos of an angle, we'll call it A, you can call it whatever you like, equals adjacent over hypotenuse. So that's what I'm going to write, ADJ over HYP. So that's our second ratio done now. And then our third and final, we've got tan. And tan is equal to opposite over adjacent. So I'm going to write tan, and we need to find an angle, we'll call it A, equals opposite over adjacent. So you don't need to memorize these ratios because that's what SOHCAHTOA is for. It's to help us to remember them. So let's flip to the next page. Make sure you've got all the notes done before you continue with the video. And we have a summary, sine, and remember that's a little symbol for theta, which just means an angle. It's like A. It's just a symbol that represents an angle. So sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. So we can use any of these ratios when we're solving for a side length or an angle of a triangle. It just depends on what we're given. And we're going to work through some problems together. So for this course, as it says in the course outline, you will need to have a scientific calculator. So your cell phone is acceptable for homework and for assignments, but on tests you are not able to use your cell phone. So you have to come to my class with a scientific calculator. You can buy them at Staples, Home Depot. I think they even have some at the dollar store. So I need you to take out your calculator now, whether it's a cell phone or a scientific calculator. If you have a cell phone, you can download a scientific calculator app. They're free and they're great. So if you've got your calculator ready, we're going to do two different calculations. We're going to calculate side lengths and then we're going to calculate some angles. So for side lengths, it's really easy. We have this side length A equals sine of 25, and it says to find A. So all we have to do is type sine 25 into your calculator. So if you type sine 25 into your calculator, and we're going to take two decimal places, you find that A equals 0.42. If you did not get this answer, there's two possibilities. One, some calculators work opposite. Instead of typing in sine then 25, you might have to type in 25 and then hit sine. So try that. If you're still not getting the right answer, look on the screen of the calculator. It should say DEG, degrees. That's because see this little degree sign, that we're looking at angles in terms of degrees. If it says RAD or anything else, you're in the wrong mode. It has to say DEG. So you're going to look, if it doesn't say DEG, you're going to look on your calculator for a button where you're going to be able to change the mode to DEG. Okay, so once you've done that, triple check that you're getting the same answers as me, and let's keep on going. So now we're looking for the side length r, and it equals cos 50. So you're just going to type in cos 50 equals into your calculator. And if we round to 2 decimal places, you should get r equals 0.64. And let's keep going. My suggestion is pause the video and try C and D on your own, and then just fast forward and triple check your answers. Alright, so now we're going to try Q, and we know that Q is equal to sine 190, so you're going to put that into your calculator. And it is a negative number, and that's okay. Q is equal to negative 0.17. And last, you're going to check D. We're looking for X, and X is equal to cos of 225. So you're going to plug that into the calculator, and you'll get X is equal to negative 0.7 and 1. Don't forget that we need to round to that 1. So side lengths are quite easy to calculate. What we're going to do now is practice calculating angles. So looking right here at A, we see that we're looking for the angle A, and it says that cos of A equals 0.4067. So we can't put cos A into the calculator. It's not so simple as above. We need to get A completely on its own, but what's in the way is this cos. So we've got to move this cos onto the other side. So from your algebra knowledge from your previous math courses, you know that if we want to remove something from one side of an equation to the other, we have to apply the opposite to it. So a short form of what ends up happening is that when we want to get rid of something, it ends up becoming the opposite of itself on the other side. So the opposite of cos, I'm going to write a little note, the opposite of cos is, take a look at your calculator, and you'll see the cos button. And take a look on top of the cos button. It should say a little something like this, cos negative 1, which is called cos inverse. So that is the opposite of cos, just like the opposite of sine would be sine inverse. So when we want to take a cos and remove it to the other side, it becomes the opposite. And the opposite is going to be cos negative 1. So when we rewrite it, we've got an A left on this side equals, we're going to change this to cos negative 1 of 0.4067. And you're going to throw that into the calculator. So to get to cos negative 1 on the calculator, it's usually in yellow. You need to press your yellow button. It could be called shift, it could be called second, it could be called a lot of things. So just get creative, and if you got the right answer, you should get 66 degrees. Okay, so let's move on to the next one. So we're finding angles here. So we're looking for A. A is not by itself. We've got to remove this sine. So we're going to apply the opposite. And the opposite of sine is going to be sine negative 1. So when I rewrite this, I'm going to write that A equals, I'm going to move the sine over. So it becomes sine negative 1 of whatever this number is. So 0.7777. And you're going to throw that into the calculator. And if you get the right answer, let's round to 1 decimal place, you will get 51.1 degrees. And let's keep it going. I'm going to put a little divider here going over. Okay, so again, we got to remove this sign so that A is by itself, bring it onto the other side, and we have that A is equal to sine negative 1. I'm just going to put it below because we don't have enough room. Sine is equal to, sorry, a is equal to sine negative 1 of 0.2861. Okay, and you're going to throw that into the calculator, and you'll get 16.62 degrees. Oh, and we just, you know, let's be consistent. I'm going to round to 1 decimal place. Okay, and let's work on the final one here. We have cos A equals 0.7139. We want to get A by itself, so we've got to remove this cos. We're going to apply the opposite. It's going to be cos inverse, or cos negative 1. So we're going to be left with A equals cos negative 1 of whatever this is, 0.7193. Throw that into your calculator, and you will get 44.0 degrees, and this was 0.0 degrees as well. Okay, so if you think you've got that covered, we're ready to work on some actual problems here. So there's really only 3 kinds of problems that you can get with SOHCAHTOA. 2 of them are finding 2 different kinds of sides, and the other is finding an angle. So let's deal with the 2 types of questions you could get for finding a side. So here we've got a triangle, and it says find the length of side C. So we know we're looking for a side length. No matter what we're looking for though, when we have a right angle triangle, first of all, we know we can use SOHCAHTOA because SOHCAHTOA is good for right angle triangles. But the first thing that we have to do is we have to label. So we're going to use the labels that we learned on the first page, hypotenuse, opposite, and adjacent. So the first one we're going to label is the hypotenuse. And we know that the hypotenuse is across from the 90 degrees. So it has to be this one here. So I'm going to write HYP. And then the next we're going to label is opposite. So we've got 2 options, 1 and 2. Any ideas? Well, if you remember from our notes, we have to take the angle we have, which is this angle right here, and we have to go across the triangle. So this must be the opposite side. So I'm going to write opposite here. And the leftover side has to be adjacent, ADJ. If you want to write yourself like a little semicircle here to make it clear this is the angle we have, that's fine. Alright, so even if you learned it from another way from another teacher, and you get the right answer every time, absolutely go for it. If you can't really remember how to do it from grade 10 and 11, just follow my lead, and then you come up with shortcuts yourself. So the first step is to label. The second step is to list what we have and what we need. So we're always given 2 things and we need 1 thing. So in this case, what do we have in this triangle? Well, we have this 12 centimeters. So we're going to say that we have the hypotenuse. So we're going to write have HYP, and I'll put in brackets, it's 12 centimeters. What else do we have? Well, we have the angle 25. We have the 25 degrees. So we have 2 things. What do we need? We always need 1 thing. Do we need, it looks like we need adjacent and opposite, or we don't have them, but do we need them both? No, we don't need adjacent. All that this question is asking us for is find the length of side C, so we just need opposite. So I'm going to write that we need opposite. So if we did this right, we should have 2 things that we have, check, check, and 1 thing that we need. Perfect. And in our list, there should be 2 side lengths. So I have hypotenuse and opposite. So from our list, from these 2 side lengths, we can figure out whether we should use sine, cos, or tan. So the next thing that I'm going to do is write out SOHCAHTOA. Okay, so we are looking for either sine, cos, or tan to match up with these angles, or these side lengths. So we're looking for a ratio that uses hypotenuse and opposite together. So let's check. So sine, let's go through it, uses opposite and hypotenuse. This looks good. Cos uses adjacent hypotenuse, so cos is not helpful. Tan uses opposite, that's great, and adjacent, not helpful. So the only ratio that's going to work is sine, and there's only going to be 1 ratio. So because hypotenuse and opposite matches with this here, hypotenuse and opposite, therefore we will use sine. So now I'm going to write out my ratio. So we know that the sine of an angle A equals opposite over hypotenuse. And now let's fill in the information that we know. We have the angle. So instead of A, I'm going to write sine of 25 degrees equals, we also have opposite. So instead of OPP, I'm going to write C over, and instead of hypotenuse, we've got 12. So I'm going to write over 12. So now the goal, remember, it's just a little bit of algebra, is we are going to solve for side C. So this just requires a little bit of algebra. We know that we want to remove this divided by 12. So anytime you want to remove something, you just apply the opposite of it. So the opposite of times 12 would be, the opposite of divided by 12 would be times 12. So I'm going to multiply by 12 on this side and multiply by 12 on the left side. 12 divided by 12, those are just going to cross out. And we're left with 12 times sine 25 equals C. You're going to throw 12 times sine 25 into the calculator, and you will get 5.07 centimeters. We're rounding to 2 decimal places. So if your previous teachers taught you a different way to do algebra, please go ahead and use it. As long as you get the same answer as me, it does not matter. So this is one type of example. Let's go on to the next type of example. If you don't understand this one, I highly recommend for you to pause and rewind this example and look over it again. And don't copy down the notes until it makes sense to you. So if you understand this example, let's make it harder and go to the next one. So the next one looks very similar. We are looking for a side length again. So we're on example 2. So we are going to approach it in the same way. The first step, if you can remember from the previous example, is just to label. So let's go ahead and label. Let's find the hypotenuse first. We know it's going to be across from the 90 degrees, so we're going to write HYP here. And then we're going to look for the opposite side. The opposite side is going to be across from the angle that we're given or that we're looking for. In this case, it's the 30 that we have. So this has to be the opposite because it's across the triangle from the angle. There it is. And then the last, this has to be adjacent. Do you remember the next step? The next step is going to be writing out the list of what we have and what we need. So let's write out what we have first. So in this case we have, can you see? I see 24. We have adjacent, which is just 24 centimeters. So we have ADJ, adjacent. You can put 24 if that makes you feel better. And what else do we have? We also have the angle. So we have 30 degrees. And what do we need? We need T. Don't be confused. We do not need the opposite. We don't have it, but we also don't need it because it doesn't ask for it. It just asks for T. So the only thing that we need is hypotenuse. Need HYP, which is just T. So if we did this right, we should have 2 halves and 1 need. Check, check, check. And if we did this right, there should also be 2 side lengths. And here they are, adjacent and hypotenuse. So now we're going to do a little matchy-matchy. We're going to match it to SOHCAHTOA and see whether this matches sine, cos, or tan. So remember, we've got sine, we've got cos, we've got tan. So let's take a look at sine. We're looking for something that matches adjacent and hypotenuse. Can we do it? Sine uses opposite and hypotenuse. No, that does not match. Cos uses adjacent and hypotenuse. It matches. And let's just triple check tan. Tan uses opposite and adjacent. That does not match what we have. So adjacent hypotenuse matches our adjacent hypotenuse. So we're going to use cos. So I'm going to put therefore use cos. So let's write it out. We have cos of our A equals adjacent over hypotenuse. So now that we have our formula, we can write everything in. So, do we have our angle A? Yes, we do. It's 30. So I'm going to replace A with 30 equals. Do we know what adjacent is? We do. It is 24. So let's put in 24 all over hypotenuse. Do we have hypotenuse? No, we don't, but we can just replace it with T if we want. There we go. Okay, so this looks very, very similar to the previous example. I'm just going to switch to it. The only difference is what we want here is at the bottom of a fraction. If you switch over to the previous example that we just did, what we wanted, the C, was at the top of the fraction, so it's very easy to move this divided by 12. So it's not impossible, it's just an extra step for us. So there's lots of different ways to do this. If you know how to cross multiply, you can put this over 1, you can cross multiply that. If you don't know how to cross multiply, I'm going to show you what I think is the easiest way to do it. So this T being at the bottom here is a problem because even if we move this 24 onto the other side, we're still left with 1 over T. We want that T on the top of the fraction. So if it's not on the top of a fraction, we can make it on the top of a fraction by just flipping it. That's it. We're just going to flip this fraction. But we can't just do magic and flip one fraction and not do anything to the other side. Whatever the basic rule is in math, if you have an equation that balances or an equation that equals each other, if you do something to one side, you also have to do the same thing to the other side. So if we're going to flip this fraction, we also have to flip this fraction. But this does not seem to be a fraction, so we have to make it into a fraction. And you can make any number into a fraction by putting it over 1, because anything divided by 1 is still that same thing. 10 divided by 1 is still 10. A million divided by 1 is still a million. Miss Elizabeth divided by 1 is still Miss Elizabeth. So cos 30 divided by 1 is still cos 30. So we haven't changed the equation. So we want this T on the top. No problem. Let's make it on the top. So we're going to flip this side and we're going to flip this side. So when we flip them, it's going to look like this. We're going to have 1 over cos 30 equals T over 24. So we just flipped it. And now this has become simple algebra. We want T by itself. No problem. It's at the top now. Everything's good. We're going to get rid of this divided by 24 by multiplying by 24 on this side and multiplying by 24 on this side. These two cross out, and we've got on the left side 24 times 1 over cos 30. And if you throw that all into the calculator, you get 27.71, if we're rounding to 2 decimal places, equals T. So there is our final answer for T. So this is our second of 3 possible examples that we could be given in SOHCAHTOA. So one is finding a side length where what we need is at the top of the fraction, no problemo. The second is finding a side length where what we need is at the bottom of the fraction. And the last type of question that we could be given is where we're looking for an angle, not a side length. So in this case, it says to find angle A. So I again urge you, if you did not understand that previous example, pause it, rewind it, make sure you've got it. Email me if you have any questions. And then when you're ready, let's move on to example number 3. So example number 3, just a reminder, is asking us to find an angle. We're going to start the exact same way. First thing we're going to do is actually switch the video because I'm about to run out of time. So go ahead and click on lesson 1.1 example 3 video now.